All right, this lesson is on adding and subtracting fractions using real-world problems. So this lesson assumes that the student has had success with adding and subtracting fractions and that the aspect of the standards that is getting them is the real-world problems aspect. So this is going to go through some strategies to help them with the real-world problems aspect. This is really good for the students that are ESOL, the students that have IEPs or might be struggling readers. This is great for that. All right, so we will start off with our math vocabulary. So I like to use Quizlet with math vocabulary. So for this lesson, we're going to use Quizlet. All right, so this is Nearpod, and Nearpod allows you to have a link inside of it. So these are the math vocabulary terms that we're going to talk about. So when we're talking about addition, you're going to see words like add, altogether, both, combine, how many in all, increases, join, plus, together, sum, total. Subtraction words would be difference, deduct, decrease, how many more, left, minus, less than, remain, subtract, and take away. At this point, the students would now have access to Quizlet. This link becomes available to them. The link is down here at the bottom for them, and they have access to do the activities with this. So at this point, I would ask them to click on the Learn section in Quizlet so that they can practice. Now, when they get comfortable with it and if they open the Quizlet window separately, they can go in and they can see the test section here. So once they feel comfortable, they can do the test section. And I would let them know that when they were able to make an 80% on the test section, that they were really ready for what we were going to do next. So I would give about 5 minutes for this. I want them to have some time with it, but I don't want them to reach frustration. Quizlet is really good at giving them the opportunity to go through and practice and get comfortable with these vocabulary words. I want them to get used to seeing these words so that they can pull them out when we're working on them with real world problems. Because a lot of times the kids see all these words and they just don't know where to start. So the purpose of this is for them to see where to start. All right, so this is my timer that I would use, and I would put my 5 minutes on there for them. They would have the timer available to them as they were practicing. All right, so now that they've had practice with those vocabulary words, we're going to go into what's called the cubes strategy. So with the cube strategy, it says that we need to circle our key numbers and units. We need to underline the question. We need to put a box around our math clue words, and we need to evaluate. So once we have all those things pulled out, we need to figure out what our next step is. And then once we figured out what we're doing, we have to take the time to solve. Okay, so once we figure out what our problem is asking, then we have to solve the problem after we've put out all the extra words and turned it into your normal math problem, like what the kids are used to seeing with just an addition or subtraction sign and their fractions. Okay, so we would model here. Okay, so at this point, we're going to model the cube strategy. So we're going to practice using them together. You're going to follow along as I do it. Okay, so it says the Penguin Nursery is open 2 times a day, 2/3 hour at noon, and 5/6 hour in the afternoon. How much time is the Penguin Nursery open altogether? Okay, so my first step in cubes said I had to circle my numbers and their units. Okay, so number here, and then the unit is what tells me 2/3 of what. Okay, so I have 2/3 of an hour. Please notice that I made sure to read my problem first before I started picking out all my details, because I want to make sure that I have the whole thing before I start pulling stuff out. I don't want to find myself with information I don't need. All right, then I said my next unit was 5/6 of an hour. So I'm going to put a circle around that. All right, my next step, let me make this a little smaller for us so it's easier to see. Okay, my next step is to put an underline on the question. So it wants to know, how much time is the penguin nursery open altogether? Okay, how much time is the penguin nursery open altogether? All right, well, altogether is one of my math keywords, and my next step in cubes is to put a box around my clue words. So those clue words that we talked about before are still important now. So all together gets a box. Okay, so now I have to evaluate. So when I'm saying evaluate, I mean, what am I doing? What numbers do I have, and what am I doing with them? So I'm going to go look at that clue word that says all together. All together tells me that I'm going to add. Okay, so that means that this is going to have an addition sign. So let me see if I can grab, let's do this a different color here. All right, so I'm going to do an addition problem. So I have all together. So I'm going to add. All right, and it wants to know how much time. Well, it says it's open 2 times, and my 2 times were 2/3 hour and 5/6 hour. Okay, so that means that I have the problem 2/3 plus 5/6. Now, I'm going to go back to my knowledge of how to add fractions when they don't have the same denominator. So I can make myself a pretty little picture with this one. It's really nice and easy. Okay, I could do it that way. Or I could use my greatest common factor method. Okay, so for time's sake, we're going to do the greatest common factor method, and then we'll check it with our picture method to make sure that we did it right. Okay, so I need to know, what is the greatest common factor of 3 and 6? Sorry, not greatest common factor, least common multiple. What is the least common multiple of 3 and 6? Because remember, multiple means multiply. So I'm multiplying my number times something. Okay, so I need to find my least common multiple. All right, so I would say, counting by threes, I get 3. Sorry, I don't know what my pen is doing here. Maybe I'm bumping my mouse. Okay, so I'm going to count by threes. So I have 3, 6, 9, 12. Okay, next I'm going to count by 6. All right, so next I'm going to count by 6. So when I'm counting by 6s, I get 6, 12, 18. Okay, I'm going to stop there for now. All right, so I want to know, what is the smallest multiple they have the same. Remember, multiple means multiply. That's why I counted by that number. Okay, so the smallest number they have the same here is going to be the 6. Just gonna be a little highlighter here. Okay, so my smallest number they have the same is 6. All right, now I need to ask myself, what am I multiplying by to get 6? Well, to multiply 6 times a number is just 1. So 6 times 1 is 6. So that means that this fraction here gets to stay the same. Hooray, I only have to change one fraction. Okay, all right, but I do have to change this fraction. So I need to ask myself, 3 times what gives me 6? Well, I have an easy way to do that here because I just counted my multiples. So 3 times 1 was 3. 3 times 2 is 6. And then 3 times 3 was 9. And I could keep going if I wanted to. But I'm going to stop because I have 6 and that's what I needed. So 3 times 2 is 6. Now, Remember, when we change a fraction, we're making an equivalent fraction. That means it takes up the same amount of space, all right? So that tells me that I need to do the same thing to the top and the bottom of this fraction. I can't do it just to one thing because I'm making an equivalent fraction, so it has to take up the same amount of space. So I'm going to multiply the 3 by 2, if I can write a 2, and then I'm going to multiply 2 times 2, okay? It's not a very good 2. All right, 2 times 2 is 4, remember? And then 3 times 2 is 6. So that tells me that I now have the problem 4, 6, plus 5, 6. Okay? Now, refresh our memory on how we add and subtract fractions. So we did our step 1, we got our common denominator. Then we did our step 2, we converted our fraction so that it had the same denominator. Now we're going to do our step 3, which is add the numerators. So our numerators are 4 and 5. So we have 4 plus 5, which would be 9. Right? Now, remember the fraction, the bottom stays the same, okay? Because we're not changing the size of the slice. We're counting the slices, that's the numerator, but we're not changing the size of the slice, okay? So this would be a 6 on the bottom, okay? So 6/9 of the day is how long it's open, okay? 6/9 hours, okay? Now I can change this and I can simplify it down, okay? So if you've gotten the process, now you can go the extra step and simplify. So to go the extra step and simplify, I need to ask myself how many 6's are there in 9/6? Because remember, 6/6 is equal to 1 whole, right? So how many 6's are in 9? So I already have my multiples of 6 up here. Well, 12 is too big, so it can't be 2. But 6 is the right amount. So I can do 9 minus 6, and that would give me 3. So that means that I have 1 whole. That's my 6/6. So I took care of this with 3 6 left over. Okay. I can always check myself by drawing a picture. So if I wanted to draw a picture, I would give myself 2 circles. And these are not going to be the most beautiful circles, but we know that they're supposed to be circles. Okay. I would divide one circle into 3 pieces, and the other circle I would divide into 6 pieces. All right, so now that I have them divided, I have to shade them in. So I have 2/3. Doesn't really matter what color I use here. So I'm going to shade in my 2/3 here. Okay, so 1 2/3. And then I had 5 6. So I have 1 2 3 4 and 5. Okay, now I wanted to make them the same size slice. That's where I found my common denominator. I was trying to make the same size slice. So the way that I did that was that I turned a 3 into a 6. Well, I can do that by taking my 1/3 pieces and cutting them in half. So if I were to cut each of my 1/3 pieces in half, I now have 6 pieces. So I can count them 1 2 3 4 5 6. Okay, so we're just visually representing what we did mathematically up here. All right, now that we have found that, we can say, all right, well, how many pieces are shaded? So we have 1 2 3 4 of those pieces shaded. So this is where your 4 6 came in. Now that I have my 4 6 and my 5 6, I can add the way that I'm used to adding. Okay, so I did the mathematical way, and then we checked it with a picture to make sure that we had broken it up correctly. Okay, So make sure you're using your cube strategy. Make sure you're remembering your steps for adding and subtracting, and you will be just fine. Okay, so this is the problem we just worked, and we practiced it together. All right, so we're going to go through another example, and this time you're going to kind of follow along with me while I'm doing it, okay? The first step we have to do is read the entire problem, okay? So we have to read the entire problem before we do anything. So it says the coffee shop also sells small bags of coffee beans. The bags come in two sizes, 4/5 kilogram and 7/12 kilogram. How much more coffee does the bigger bag have? All right, so we have to start with, they have two sizes. Okay, so those are my two numbers with their units. So remember, our cube says the first step is to circle numbers and their units. So we have to circle these. So let me make sure we are doing this correctly. So we're going to circle our numbers with their units. Kilograms is the units. That's how we're measuring it. All right, then we have our 7/12 kilograms here. All right, next step says to underline the question. So our question here is, how much more coffee does the bigger bag have? All right, third step, the B says put a box around what our keywords are, the words that tell us what we're doing. So the key words here are how much more. All right, now that we have pulled out our important details, we have got to evaluate. That's our E. So we need to figure out, what are we doing here? When I see how much more, that tells me I'm going to subtract. Okay, now here's the fun part. It says the coffee shop sells small bags of coffee beans. The bags come in two sizes, 4/5 and 7/12. Do I currently know which one of those bags is bigger? No, I don't currently know just off the top of my head. So since I don't know off the top of my head, and it doesn't tell me in the problem which of them is actually bigger, the first thing I'm going to have to do is find the common denominator and convert them to fractions. I have the same denominator, so then I can really compare them, okay? So I am going to have to find my common denominator first. So I have 4/5. I'm just going to pull this out because we're not ready to set up our subtraction problem yet. So we have 4/5, and we have 7/12. Okay, and we have to turn them into equivalent fractions with the same denominator. So I'm going to use that least common multiple strategy again. So I'm going to count by fives first. So I have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, make sure I leave room to count, 55, 60, I'm going to stop there, okay? All right, and then I'm going to count by my 12. So I'm going to do this in a different color so we know which one's which, okay? So I'm counting by 12s next. So 12, 24, 36, 48, 60. All right, I just found a number they had the same, so I'm going to highlight it. So the number they have the same is 60. All right, so I need to figure out how to convert these both to a denominator with 60. So I'm going to go ahead and set up my problems so I know what I'm doing here. So I'm turning 4/5 into a problem that has 60 on the bottom. And then I'm turning 7/12 also into a problem that has 60 on the bottom. All right, so I need to figure out what I need to multiply by to get 60. So I'm going to start with my fives. So when I start with fives, I have to count. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, It apparently doesn't want to draw for some reason. 10, 11, 12. So I had to do 5 times 12 to get 60. Okay, so 5 times 12. So if I did times 12 on the bottom, it means I have to do times 12 on the top. So 12 times 4 is 48. So the equivalent fraction here would be 48. All right, now I'm going to go look at my 12s. So 1, 2, 3, 4, 5. Okay, so 5 times 12 gave me 60. So that means I have to multiply by 5 on the top as well. So 7 times 5 is 35. Oops, let me do that in the right color. So I'm going to put 35 up here. All right, now I can easily tell which one's the bigger fraction because they have the same denominator. So now I can compare the numerators and I see that the bigger number is 48. Okay, so my problem is going to say 48 sixtieths and minus 35 sixtieths. Now, in this instance, I can't just go draw a picture. It's not that simple. So that's where this least common multiple strategy really comes in handy. So we can draw the picture when we have fractions where we're only having to change one fraction, and it's really easy to visualize that. But when it gets more complicated like this, yes, I can cut the pie into 60 pieces. Do I want to have to take the time to figure out that I need to cut the pie into 60 pieces? Not really. So the least common multiple strategy is super helpful. So just don't forget about that when you're working through these, okay? All right, so now I'm ready to subtract. So I'm just subtracting my numerators. So that means I have 48 minus 35. And 48 minus 35 is 13. My denominator stays the same, so it's 60. So I have 13 sixtieths kilograms. If it'll draw. All right, so I solved that I had 13 sixtieths kilograms. All right. So now we're going to work one together. So you're going to get the chance to go do it for yourself. Then we'll come back and revisit it together. So it says, assume you're making trail mix for your family. You want to know how much trail mix you'll have after you've completed a batch. What can you do to figure this out? So this is your ingredients. So you're going to answer here on this draw section, and you will be able to draw what you think your answers would be here. Okay, so I should be seeing your work about how you think you would solve this. Do you think there would be an addition? Do you think it would be a subtraction? How would we make this happen? Okay, this is more complex than what we've been doing. At this point, I would let the students work, let them work through it. I could monitor what they were doing here because the Nearpod is great about that. So that's what this the purpose of putting it in Nearpod is. And it would pop up what their answers were here. Next, I want you to explain to me why you chose this method. So think about your problem. What tipped you off that that was what you wanted to do? Were there some math keywords that stood out to you? Is it something that you know from personal experience or that you're used to doing in like at home if you work on if you do recipes at home? So what really made you choose the method that you chose? Okay, at this point, they would be able to put in a short answer question. I would be able to get their answers here. And this would help me monitor and make sure that they're finding those keywords that we went through at the beginning so that they can really figure this out. Maybe I can see some of the cube strategy coming in here where the kids are talking about, well, I circled the numbers and then I put a box around my keyword and I underlined my question, and that's how I figured it out. Okay, that's what I'm looking for here. So then we would go on to work this out together. And then I would bring it up to the next level for my kids that were doing really well with this. And I wanted to give them a little bit more of a challenge So I would ask, what if you wanted to separate it into 3/4 cup servings? So what I would be looking for them to do here is come up with the need for repeated subtraction, because we're working solely with addition and subtraction. But I would give them the opportunity to kind of think through it here with another draw activity. So in this activity, they would go through and they would show out their work of how they think this would happen. Hopefully a lot of them would go back to, well, I can pull out 3/4 until I get to the end. Okay, so that's what I would try to make happen here. Being able to see all of that with the draw is also really good too, because I can see, oh, that kid's ready for this. That kid might need to do a little more with that. And I would open my whiteboard up after they had gone through it and explain why they did it how we did it that way, so that they were prepared if they saw a question like that in the future. All right, for their independent practice, they would answer questions on a Google Doc. I chose Google Docs because it's really great for translating. So if there's a student that's ESOL, then they can go over here to the tools and they can tell it translate document. So if they've made a copy of it, then they can translate it. I don't think it automatically does it if they haven't made a copy already, but this will make a copy that's translated. So if you have a kid that can't do it, then they have this opportunity. I would go through with them how to work through the Google Doc. The best way to do it, in my opinion here, with some fraction models is to do it with pictures like this. So some of them will have fraction models, some of them won't. Like this one, you probably aren't going to make a fraction model for that. That'd be a little crazy. They could if they wanted to, because the great thing about Google Docs is that they're not sitting here trying to draw forever and ever. So then they're not having to draw like a million boxes. They can just go tell the graph how many boxes they want. So they could do it that way. But I'm really looking to see what their work is. So they can work it out here. They're showing their work over here. They're typing in what they did, and they're putting their answer out here. So I can easily look at the solution side and see, yes, this kid has the answer, or no, this kid doesn't have the answer. Maybe I should go look at the work and see if I can figure out where the misconception is coming in. I also put in a real world scenario like what we did towards the end. I know that that's more of a higher level thinking, so I don't want to make it super heavy with that. I want them to get used to seeing the style of problems they would see on, say, like a test in the future. But they do need to know the real world connection because that's part of their standard. So I want to make sure that that gets included in what we're talking about here. So they get their recipe involved, they get to put it all together and figure out how much batter they're going to have. And then the extension activity, like what we did in our practice, completely lines up. So they have repeated subtraction here for their bonus. So if that really stood out to them or they're doing really well with it, then that's an opportunity for them to show me that they understand the process of repeated subtraction here. Let's see if there's anything I missed. So like I said, I highlighted the keywords and the vocabulary. Keywords and the vocabulary is so important with the kids that really struggle with this stuff, because you have to be able to read past all the fluff and see what actually matters. And that's really Cube strategy is really great for them. That's why at the end of my lesson, when I'm sending them off to go work on their stuff, I'm making sure that I keep up the Cube strategy for them so that they can go back and reference it. I'm also keeping up the keywords so that they can go back and reference that chart as well, so that they know what they're looking for, because the more you practice with that stuff, the better you get at it. And Cubes is really great for the reading struggling kids. And of course, how I would determine if they had been successful. So the goal is to get 80% accuracy on the Google Doc practice that I showed you. So if they can do 80% accuracy on that, then they can prove that they understand the content. I'm also a firm believer in allowing kids to retry and take more attempts at things. So the goal is for them to understand the content. So I would have made sure that they shared those Google Docs with me so that I could be watching their Google Docs as they went. And the great thing about the Nearpod as well is that I can track for any misconceptions along the way to do any intervention that I need to do to target certain kids. So if I had kids that were really struggling during our Nearpod lesson, then I'll know when they're working on their Google Doc, if they still seem like they're struggling towards the end of the lesson, okay, I need to watch this kid's doc and figure out where the misconception is so that I can meet with them and we can get it all sorted out. Or I can use the understanding of misconceptions that they had during the Nearpod lesson. Maybe if I didn't have a chance to stop because it was just one kid that was struggling, then I can really hit with that one kid on what they're going to need to do to help solve the misconception.